Okay, so I want to begin with a coding question for all of you. Let's see how far we go with that question. So you have, let's say I'm putting something here. And let's take another array B. So we have, let's say this. So what is your observation about these two arrays? Can you respond in the chat? What are you observing in these two arrays? Is there anything special about these two arrays? Awesome. Yes, they both are sorted in ascending order. So what essentially the question is, we are given two sorted arrays, A and B of size AN and BN respectively. So you can assume size of A is AN. So AN value for this is 2 to 415 and this array BN 2 to 426. So we have two sorted arrays and your result that you want is you want to print all the elements of both arrays combined in a sorted fashion. So if I just ask you, you have to just, this is a printing exercise. I'm not asking for code right now, but if I just ask you the output, what is the ultimate output we would see if we want to see all the elements together in sorted orders? So what is the output we are expecting for any two inputs? For these inputs, first element will be, okay, thanks Nidhi for being quick. Yeah, so these elements that we want are output we want in this manner. Okay. So simple problem statement that we want these elements to be printed in a sorted merged fashion. Now, I do not want code from you as of now. We will first spend some time in thinking of the exercises. So given two arrays, this is the output you want. Think of any approach and logic in your mind. I don't want you to reveal the approach or logic in the chat. What I want you to type in the chat is whatever approach you have in your mind, what is the time and space complexity of that approach? In chat, I want responses from all of you. If this is the question, whatever approach you have, idea you have, no code as of now. So refrain from coding anything at the moment. Let's focus on just coming up with any approach. Okay, so one response I got. I want responses from everyone. Pawan, I'm not asking approach. I'm asking time and space complexity. So I need in response time and space for your approach. It can be any approach. I'm not caring at the moment about your approach. Okay, although whatever responses you are giving, they are efficient approaches, but I want to start with multiple approaches. So if I just ask you, let's begin with first approach. Let's say if I allow you to use another array C, the simplest approach is, if you are allowed to take array C and you want to copy all the elements of first array and second array, then what should be the size of array C? AN plus BN, because you have to accommodate all the elements of that. Okay. Now, if I say copy all the elements of A into array C, so you are copying. So first in first AN places, and after that, if you copy B to C in next BN places, now you have all the elements combined together in C. Now, if I say sort C now, and then print C. For sorting C, you can use any sorting algorithm. Let's say you use insertion sort or you use merge sort here, any sorting algorithm. These are just two options I'm writing. If this is the approach we are taking as our first approach, what will be the time and space complexity of this approach? Time wise, first step wise, if you look at, we are just declaring an array C of size n plus bn, then you are copying the elements. First step will not have any time complexity. Second step, when you are copying A elements to C, total elements in A are an. So copying will take an, that is from second step. Third, you are copying B into C, it will take bn. Now you have an plus bn elements in C. If you use insertion sort, the time complexity of insertion sort is n square. So now it is sorting will take an plus bn whole square. And after that, we are printing. So can I say printing will take another an plus bn? Are we able to visualize all these components? Okay, is everyone clear how we came up with the time complexity? Yes, great. So this is the elaborate thing. Now, if we have to kind of summarize it, then this becomes an plus bn 2 times and an plus bn whole square. If we have to describe it as big O, in big O notation, we know we get rid of constants and we get rid of less significant terms. So the higher significant term is this, the whole square of an plus bn. So that will become our big O time complexity. Okay, that is approach 1. Space complexity wise, how much space do you think we have taken extra here? Yeah, space wise, we took array C and array C's space was an plus bn. Big O wise also it is an plus bn our space. Approach 1 is that. And of course, in place of, this is with insertion sort. In place of insertion sort, if we would have used merge sort or quick sort, their time complexities are n log n. So it becomes, this term will become this into log of an plus bn. And of course, that will become your, in fact, if I call this term as total cn, I will say it is cn log cn. Okay, where cn is an plus bn. I'm just using one more term to kind of replace it. Okay, now it depends on like which sorting algorithm we are using. So first approach is that. Very naive approach, very simple approach. Approach 2, if I have to take, then what we can do is, let's say I don't want to change step number 1 and 2. I want to keep them same, step 1 and step 2. Is there something we can do about step 3 here? If A has been copied into C, then C will be sorted. Okay, yes. And then Sudipya is suggesting insert B between A. Let's try to visualize what Sudipya is saying. She's saying copy A into C. So your C array will look something like this. And C array has more spaces for 6 elements, 1, 2, 3, 4, 5, and 6. Because if you see first step wise, we are taking C array of this size. We are copying A in first few places, done. Now if you take the first element of B, that is minus 11. Minus 11, we want to insert in this already sorted array. Insertion sort wise, the way we do insertion sort, we always start from the right side. If you are inserting minus 11, what will you do? You will compare that with 90. 90 is bigger than minus 11. So what we should do? We want to insert minus 11, last element, 90 is bigger than minus 11. Yes, so we shift 90 to the right and we are creating place for 11. So 90 moves here. Then we go and compare minus 11 with 6. What happens? Should we shift 6 also? Yes. So we shift 6 also here. Then we are inserting minus 11. Compare that with 2. Minus 11 is less than 2. So 2 shifts here. Minus 11 is less than minus 5. So minus 5 shifts here. Now compare minus 11 and minus 20. So minus 11 is bigger than minus 20. So rather than shifting minus 20 here, we insert minus 11 here. So what essentially we did, we are taking for each element of B, do insertion sort of insertion of BI in C from right to left by shifting as we do in insertion sort. Idea is making sense to everyone? We understood how we inserted minus 11 here? Or do you want me to go ahead with talking about the how do we insert 3? Can I have your responses, please? Okay, awesome. We are clear. So if we are clear with this approach, I want you to give me this fourth step will be print C. I want you to give me time complexity for this approach. Idea wise, we are clear. Can you help me with what will be the time complexity if we go via this route? Yeah, guys, if this approach is clear, if this idea is clear, we should not be taking longer for thinking about time and space for this approach. Okay, so Deepa is saying Cn square, An plus Bn whole square. Others also, yeah. Ayaz is saying An plus Bn whole square. No, that is, none of these answers are correct. All the responses I have received so far are incorrect. Let's do it step by step. Okay, Sahiti says An into Bn. Harsha says M into N. Harsha, I'm not sure what is M here, what is N here. Okay, you're assuming that with the size of A array and B array. Okay, let's try to understand what is happening. So copying A into C is straightforward AN. First term is clear. Step number 2 is taking this time. Coming to step number 3, when you took first element of B and now you are inserting that in C, how many elements C has already? When you took the first element and you were inserting into C, how many elements C had? It had AN elements. When you are inserting, let's say, any element here, how many elements need to be shifted to insert first element? Worst case, to insert the first element of B, how many elements you will have to shift? You'll have to shift AN elements. Okay, so let's take that scenario. So you have A, I'm just putting some values here. I'm taking B, I'm putting some values here. And what we are trying to say is in C array, you will have X, Y, Z already present and spaces will be there to accommodate B also. So what we are saying is if we are inserting A, worst case, we will be shifting AN elements. So that means we are talking about A will get inserted here and that will require us the shifting of 3 elements. Now, if I ask you the next question, when we have to insert B, how many elements C has? When we are inserting second element of B array, how many elements are already there in C with which we have to do the comparison? An plus 1, one more than the previous. Okay. Now, if you are inserting B, how many elements in worst case you will have to shift? Worst case, how many elements you will have to shift? Is it really An plus 1? Pay attention. A that is there in these elements, that A is already smaller than B, because B is also a sorted array. That means we will never have to shift A. If we have to shift in worst case, we will have to shift X, Y, and Z. I hope this is making sense to everyone, that we are not shifting An plus 1 elements. Worst case, we will be shifting An elements only. Right? So for first element of array B, we will be having An element shifted. For second element also, we will have maximum Bn element shifted. For third also, maximum Bn element shifted. So overall, can you tell me in each step, if you consider, when complete B array is copied here, how much processing will be involved? It is An into Bn, Sudipya. Right? So An is the number of elements we are shifting. So this becomes time complexity of this step where we are doing insertion. And in the end, we are printing C. Printing C will take An plus Bn time. Big O wise, if I ask you what is this time complexity, there are three terms. Which term is more significant? That is An into Bn. Okay. Now, is this better time complexity than previous one? Is it better than previous? If I ask you about this, is it better than An plus Bn whole square? Yes. Is it better than An plus Bn into log of An plus Bn? No. Yeah, but still it gives us some idea. And if you see what we have applied is we have applied the logic of insertion sort. Okay. So we have this as our second approach to solve this problem. Now coming to, initially many people were saying they have an approach which can solve this problem in an efficient way. Now if we talk about that, that is what I'm taking as a topic today. Approach 3. Let's say we take array C of size An plus Bn, and that is where we start. Now you compare first element of A and first element of B, and then you are filling the first place in C. C array has already enough spaces. Which element you will choose to place in this position? -20 or -11? Yes, you will choose the least element out of that because you are actually sorting. So initially your AI will be 0, BI will be 0. You're comparing A of AI, B of BI, whichever is smaller, you are putting that here, which is -20. After you have copied the element from A, which variable out of these two will change? AI will change or BI will change? Yeah, AI will change and AI will become 1. So basically you move this pointer here. Now you're going to compare -5 and -11. And now if you compare -5 and -11, who is smaller? -11 is smaller. So you will copy -11 at this index. And then B will also. So whichever element you are taking, that pointer will move forward. So this technique that we use is called two-pointer technique. So take array of size An plus Bn. What you are doing is you take AI is equal to 0, BI is equal to 0, you take CI also 0. CI is a pointer where you are copying into C array. Now you can apply two-pointer technique to solve the question. So basically, while all the elements are not copied, choose out of A of AI and B of BI copy into C of Ci, whatever selection you have done, and then Ci plus plus will always happen, and Ai Bi will move. If chosen A of Ai, you will move Ai plus plus, else you will move Bi plus plus. Idea wise, it is this, and these two pointers are moving. One pointer is moving in array A, another pointer is moving in array B. If we go with this approach, over here, what would be the time complexity? Yeah, time complexity, if you see, it will be an plus bn. To copy them into C, this loop will take an plus bn time. Then we are printing C again. That will take another an plus bn. That's the total number of elements C has. What is the space complexity here? Space is an plus bn. Yeah, this idea is two pointer technique. Now, if I ask you, do we really need array C? If I ask you this question, do we really need array C for this approach? Do we see a scope of awesome? Yeah, we see a scope of directly printing. Why unnecessary take one more array and then copy into that, and then yeah, so we don't need that. So that is another approach 4, where we want to say print directly using two pointers technique. And what I want all of you to do now is I want you to write this as a function, void print merged sorted results, and I'm writing it like a pseudocode. You have array A, you have array B, treat them as vectors in C++. I'm using it like list. It is just a notation just for keeping it pseudocode. Yeah, Python people write the code as def. So, in Python, you have two lists available. So I want you to spend some time and write approach 4 code in your notebook. Once you have written that, just type done in the chat that you are done. Okay, I want all of you to write the optimized solution for approach 4, and we'll wait for your responses once you are done. Even if you have done this problem earlier, this is a very simple problem I'm starting, but the reason I'm starting with simple problem is so that we can take everyone together. Some of you would already find this problem to be extremely easy. I see many people in the beginning itself were saying this is two pointers approach solution. But let's make sure that everyone learns from these sessions. Yeah, so quickly convert this into code and respond in the chat with done once your code is done. Okay, Prem, can you unmute and help me with the code you have written?
Yes, sir.
Yeah.
Do I am audible, sir?
Which language you write it in?
C++, sir.
Okay, go ahead.
Yes, sir. Let's first taken en, sir, which is like I have taken two vectors, sir, as a parameters.
Okay.
So en is like a dot size, sir. Bn is b dot size.
Okay, an is equal to a dot size. Bn is equal to b dot size. Okay, then
Yeah, sir. Like I have initialized two variables I and j with 0, sir.
let's call it ai and bi so that we know which pointer is moving in which array. Okay.
Okay, sir. Then there is a while loop, sir.
Okay.
The conditions are like AI is less than AN and BJ is less than BN, sir.
And BI is less than BN. Okay. Then what you are doing?
Yeah, sir. Then if AI is less than BJ, then see out A of AI, sir.
Okay. Pay attention to the variable names we are using. If you want to put BJ, I'll put BJ. And yeah, what is the line here? If
Yeah, sir. If A of AI is less than B of,
A of AI is less than B of BJ,
yeah, sir. Then see out A of AI, sir.
C out AI,
A of AI.
A of AI.
Yeah, sir.
Okay.
And increment I, sir. I plus plus.
Okay. So here you will increment the pointer of A array. Okay. Else
Else see out B of BJ, sir.
B of BJ
And
and
J plus plus.
you will do BJ plus plus. That's it.
And like one more, sir. Like if the elements are remained in A elements, sir, A array, then we will run a loop from while AI is less than AN, see out A of AI, sir.
So here you will have a loop outside or inside what you are saying.
Outside, sir. Outside, sir.
Okay. While
AI is less than,
yeah,
yes,
then these
see
two
out
lines.
A of AI.
Okay. And same way
Yes, sir. B, sir.
you will have BI less than BN and you will say, okay, this was BJ for us. So, and this was BI BJ plus plus. Okay, this is if there are elements remaining, print remaining elements of B. That's it.
Yes, sir.
Okay. Cool. Thanks, Prem.
Okay, sir.
Yeah. So Prem used 3 while loops, first, second, and third. Has anybody written the code using only one while loop rather than using first, second, third? Did anyone do it in one while loop? Okay, no. So one more way of writing this code is, okay, Ravi Teja has written. So Ravi Teja, what is the change from this code to your code?
So first I am taking I comma j as 0 comma 0, sir.
Okay,
Then an comma bn is equals to length of a comma length of b.
fair.
Then while I plus j less than an plus bn.
Okay,
Then if I is less than n and j is less than bn.
okay,
Then I am checking that if ai is less than bj, print of I plus plus.
okay.
Else I am printing b of bj and j plus plus.
Mhm.
And if the condition a less than an and j less than bn fails,
Okay.
there is one more condition, like if I is equals to an,
Mhm.
print b of j, then j plus equals to 1.
Okay.
And if and one more if condition is like j is equals to bn, then a of I and I plus equals to 1.
Fair, got your point. So ultimately, you are trying to see if one array got over, proceed with another array, right?
Yeah, yes, sir.
Yeah. So ultimately, we are saying as long as either AI is less than AN or BJ is less than BN, as long as either one array has elements, we are processing here. So few cases are if AI is greater than or equal to AN, that means AI array got over. Everyone agrees here? If AI becomes greater than or equal to AN, first array got over. That means there we have a straightforward case that we have to do only this part. If first array got over, we are printing from B. Same way, else if BJ is greater than or equal to BN, that means only A array is left. So we will go and print from A array. In all other cases, whichever element is smaller, you will go ahead with that. So if you see, in this case, we are taking care of everything in this within this while loop. Okay, both are valid solutions. Now, if we talk about time and space complexity, this helps us understand time much better. This loop, this while loop will run overall how many times? every iteration, we are printing one element. Total elements are an plus bn. Yes, so it will run an plus bn times. Here, if you see, if you come back here, this while loop will run how many times? Now it depends on the arrays, right? Yeah, it depends on the arrays, but it will print the elements until unless one array gets exhausted. For example, if we take A to B, -1, -2, -3, and B array to be 4, 5, 6, 7, 8. When first loop completes, array A would have been printed completely. Is that correct? One array would have got over. Then outside two loops, out of them, second loop would have run, first loop would not have run. Okay, and people who are saying minimum of an plus bn, that is not true, because if you see, if this was 1, 3, and 20, now tell me, will this loop run minimum of an comma bn times? Sudipya, Tushara, and Shri Lakshmi Jaina. Is this while loop really going to run equal to minimum size of an, minimum of size of an and bn? Answer to that is no. I mean, it will run as long as one array is not exhausted. Like if one array gets exhausted, then this loop will break. Okay. So some elements we can say first while loop will print, and remaining elements of the second array will be printed either by this loop or this loop. So overall, if you see, we are printing an plus bn elements. Okay. So yeah, that covers our first question, and I hope this gives good insight for us into time and space complexity analysis and just getting started with two-pointer technique. And what is the space here? Space complexity of this solution? How much extra space did we use? Big of 1. We did not take any C array. Problem was a printing problem. Yeah. So great. So it's a constant space solution. Yes. Okay. So that concludes our first problem, first motivation example. Now let's build onto this. Let's take one more similar exercise and try solving that problem.